In this video, I'll be going through how we can prove that lines are parallel using the angle theorems that we've already studied. And we can also go the opposite way and look at the angles and then prove that the lines are parallel. So we are going to be doing that in these notes today. So on top is just a review of the four theorems that we've already touched on: corresponding angles theorem, alternate interior angles theorem, alternate exterior angles theorem, and consecutive interior angles theorem. These theorems all stated that if two parallel lines are cut by a transversal, then we know that these pairs are either going to be congruent for those top three or supplementary for consecutive interior angles. And we've already practiced with those, so now we're just going to use those to help us prove things. So we're going to focus on these two proofs first and do them together, and then I'll let you try the bottom one on your own. So we are first given the information that the line L is parallel to line M. That's this line and this line. We are told that they are parallel. That's what those two symbols mean. We also know that angle 2 is congruent to angle 4. And so angle 2 is here in our diagram. Angle 4 is just this angle kind of on its own over here. So this is our given information. Remember that we always want to start by filling this in. So we know that the lines are parallel, and we were also told that angle 2 is congruent to angle 4. So now the next statement is given to us, and we can see that they're telling us angle 2 is congruent to angle 3. Well, if you look at where angle 2 and angle 3 are in comparison to the parallel lines and the transversal, we can see that angle 2 and 3 are alternate interior angles. That means that we can state them as congruent because of the alternate interior angles theorem. Then in our last step, we went from angle 2 is congruent to angle 3 to say that angle 4 is congruent to angle 3. Well, we can see above that angle 2 was congruent to these two separate angles here, so angle 3 and angle 4. Well, if those two things are both equivalent or congruent to the same thing, then we can set them equal to each other, and that is just our substitution property. And we've now proved what the proof wanted us to prove. We use the alternate interior angles theorem to make that jump. Then in our next example, we are given two sets of parallel lines now. So A is parallel to B, and C is parallel to D. We are trying to prove that angle 9 is congruent to angle 8. So when I start here and I have my given statements, I'm going to look at the next statement that was provided. It states that angle 9 is congruent to angle 11. Well, when we look at these two angles, they are going through the transversal that they're with is transversal D, and they are cutting through those parallel lines A and B. So 9 and 11 are both on the top of their parallel line, and they are to the right of the transversal. So we can say that those two are congruent because they are corresponding angles. So we're going to use the corresponding angles theorem here. That's our reason. Next, I don't have a statement, but I do know that I ultimately need to set 9 and 8 congruent to each other. They are not going through the same transversal or set of parallel lines, so we're going to have to make some sort of jump between them to be able to say that they're congruent. And as of right now, the only thing that we have set congruent to one of those two things is angle 11. So angle 11 is going to be kind of like our gateway into that angle 8 now. So if I focus instead of on 9 and 11 and I just focus on 8 and 11, you can see that those two are both inside the lines C and D, and they are going on alternate sides of the transversal B. So these are alternate interior angles, and because they are going through parallel lines, we can set them congruent to each other. So I can say that angle 8 is congruent to angle 11 because they are alternate interior angles. And that alternate interior angles theorem tells us that they are congruent. Then in my last step, we can just see that we've now set these angle 11s congruent to two different angles, angle 9 and angle 8. And so because they were both congruent to angle 11, we can say that they're congruent to one another, and that is just our substitution property for our last reason. If you'd like to pause the video and try this last one on your own, go ahead. The first statement is that the lines are both parallel, so A is parallel to B and C is parallel to D. And we can see that we're ultimately trying to prove that 1 and 16 are congruent to one another. They are not the same set, or they're not the same transversal, so it kind of looks like they're on the outside of A and B, but because they're not touching the same transversal, we can't say that these are alternate exterior angles because they're not on the same transversal D or C. So we have to take a couple steps to get here. So my first reason that was given in the proof is that angle 1 and angle 8 are congruent. Well, in that diagram, we can see that those are on the outside of parallel lines A and B. They're on alternate sides of the transversal. So we're allowed to say that these are congruent because they are alternate exterior angles. So we're using the alternate exterior angles theorem. My last step is that I'm trying to put 1 and 16 congruent to one another. But as we said, 1 and 16 are not on the same set of transversals. So we're going to now focus on how can we bridge these, because I know 1 and 8 have a relationship. So let's see if 8 and 16 have a relationship. If I just ignore angle 1 and focus on 8 and 16, I can see that those are both on the right side of their transversal. They're kind of like below transversal B, and they are to like the left of their parallel line there. So they are in the same position, which means that they are corresponding angles. And we know that the corresponding angles theorem states that corresponding angles, when the lines are parallel, will make congruent angles. So we can set angle 8 congruent to angle 16. The reason that we did this is now so that we can use substitution property again like we kind of have in the last few. We can see that we set angle 8 congruent to two separate angles, angle 1 and angle 16. So because angle 1 and angle 16 were both congruent to the same angle, that means they need to be congruent to each other. And that is because of substitution property, and we've figured out how those are allowed to be congruent to one another. We're going to go to the second page, and now we're focused on these same theorems, but we're taking the converse. Remember that the converse just switches the hypothesis and the conclusion, so we're reading our theorems backwards. We're saying that if two lines are cut by a transversal, have congruent corresponding angles, then the two lines are parallel. So if we know the angles are congruent, that's how we can prove that these lines are parallel. So we don't know the lines are parallel at first. We know some angles are congruent in some cases, and we're going to prove that the lines are parallel now. So these are all the converse of the theorems we've stated. And so when we see these congruent corresponding angles, we know the lines are parallel. If we see congruent alternate interior angles, we know the lines are parallel. Congruent alternate exterior angles, we know the lines are parallel. If the two lines have supplementary consecutive interior angles, then we know the lines are parallel. So we're kind of just going in the reverse of what we just did on the front. So we're going to prove the lines are parallel here with this first proof. It's first giving us the information that angle 7 is supplementary to angle 2. So these two are first just being told to us that they are supplementary. So the only reason we know that they are supplementary is because this was given. Then we're going to say that angle 7 plus angle 2 equals 180. That's the next statement provided. Well, we just said that they were supplementary, so this is just because of the definition of supplementary angles. In the next line, it tells us that angle 7 plus angle 6 are going to also equal 180. And this is going to be because of the linear pair postulate. We can see that angle 6 and angle 7 are a linear pair, and the linear pair postulate states that they can add up to 180. So that's our reason here. This wasn't on our notes today, but we have seen it this year. In our next line, we can say that angle 7 plus angle 2 is equal to angle 7 plus angle 6. We're allowed to do that because they were both equal to 180, and we're using the substitution property to set them equal now. You could also say the transitive property here. Then I'm using the subtraction property of equality, which means I needed to subtract something. Well, the only thing that's on both sides of this equation to subtract would be angle 7. And if I do that, that would mean that angle 2 is equal to angle 6 because I'm just subtracting angle 7 from each side. Then in the next line, it's very similar, but now we're using the congruent sign, and that's just the definition of congruence. If the angles are equal, then they're allowed to be congruent. And so now that we've stated that angle 2 and angle 6 are congruent to one another, if we look at them on the diagram, 2 and 6 are both below their parallel line and to the right of the transversal. So they are corresponding angles. Because we know they are congruent, then we can prove that those lines L and N were parallel. So this is the converse of the corresponding angles theorem. Because we knew the angles were congruent, we're allowed to prove that the lines are parallel, and that is from the converse of the theorem, not just the theorem itself, but the converse that states that if the two lines are cut by the transversal, they have the congruent corresponding angles, then those two lines have to have been parallel. So since 2 and 6 were congruent, then L and N must have been parallel. So if you'd like to try the one below on your own, go ahead. I'm going to go through it now. We're given that angle 8 is congruent to angle 2. So if we look at them on the diagram, we notice that they do have a relationship there. They're alternate exterior angles. We're trying to prove, though, that line L is parallel to line N. So we're going to say angle 8 is congruent to angle 2 because that was given. And in my next statement, I have a blank to fill in, and the reason was that it was the definition of vertical angle. So when I look at angle 2, the one that is vertical to it is angle 4. So I'm going to plug this in as angle 4. And then it's saying that I'm going to be using the transitive property, which is very similar to the substitution property. And we can see that we repeated angle 2 in both statements we've used so far. So we can use that with the transitive property to say that yellow and green, or angle 8 and angle 4, will also be congruent. So now if I look at angle 8 and angle 4 on the diagram, angle 8 is right here and angle 4 is here. They are both above their parallel line, or above their line, we don't know that they're parallel yet, and to the left of the transversal. So since they're in the same location, they are corresponding angles, and we already know they're congruent, so because we know the corresponding angles are congruent, that is our proof that the lines are parallel because of the converse of corresponding angles theorem. Because the angles were congruent, we know that these lines must have been parallel.